so worksheet 28 and 29, we didn't quite finish when we had our remote week because there was a couple questions on bearings, and I'm going to go over those today. Anyway, and then you are going to finish this worksheet for homework tonight, the purple one. Okay. So our learning targets today are just to review sines and cosines and review those two area formulas and show you some examples of bearings questions. All right, there are several different ways to measure bearings. We are going to do bearing applications that measure the acute angle that a path makes from a fixed north-south line, always measuring off of either north or south. Okay, so this is on worksheet 28B. This little box is right next to number 3. Everybody find it? It says 2 ships leave a port at 8 a.m. Oh, already I remember this has a rate time distance application. All right, ship A sails with a bearing of north 68 degrees east. That means off of north. This ship was sailing off of north 68 degrees towards the east. At a speed of 17 miles per hour, this is ship A, and its rate is 17 miles per hour. All right, ship B sailing with a bearing of off of south 35 degrees towards the east. At a speed of, this is ship B, and ship B's rate is 12 miles per hour. If the ships maintain their paths, how far apart will they be at 2 p.m.? Okay, so 8 a.m. to 2 p.m., anybody? How many hours is that? 6 hours, okay? So can we first of all figure out how far ship A would get? If we do rate times time equals distance, ship A would be 17 miles an hour times 6. Somebody help me. That ends in a 102. Is that right? Okay, that's 102 miles out for ship A. And then ship B, rate times time would be 12 times 6, I think is 72. Somebody check me. 72 miles. Okay. We want to figure out how far apart they are. From here to here is our X. Now, anybody think about how we could find this angle? I know drawing these is tricky, okay? But if you have this information, can you find that third angle in there? What do those 3 angles altogether have to total? 180 because of the north-south, everybody good? So 180 minus 68 and 35 leaves, is it 77? Okay. Now how are we going to find side X? Does anybody remember? To use law of sines, we have to have an angle and a side across from each other that we can use as our proportion, which we don't have here. So that leaves us with law of cosines. And law of cosines, anybody remember how that goes? I guess we could call this side C if we were doing the ABC thing. The side squared equals the squares of each of the other 2 added together, and then it's minus 2 times the 2 we know times the cosine of the angle in between. How many of you knew that? Got that down? maybe half or less. How many of you are going to have that down by Wednesday? Okay, so the two sides are 72 squared plus 102 squared minus 2 times 72 times 102 times the cosine of 77. What mode do we need to be in? Degrees. Yes, this angle is 77 degrees. So going to the calculator, mine is in radians, so I need to switch to degrees. I go mode, arrow down, degrees, hit enter. Now it should say degrees at the top, or if you're double checking, you could just do like the sign of 90. Should be 1, okay, to check that you're in degrees. But then we are typing, I already forgot. Was it 72 squared plus, was it 107? 102 squared minus 2 times 102 times 72, all times the cosine of 77. Okay. I don't know if you remember from law of cosines, but you cannot hit enter anywhere along the way in here, okay? You could do things in pieces, but all of this chunk has to be multiplied together back here, okay? So I got 12,284 almost. Is that the answer? Is that how far apart the ships are? That's the c squared. So we still need to square root that. So when we square root that, I got 110.8. So I had c squared equals 12,283.9. C, when I square rooted that, I got 110.8. How we doing? Is anybody not getting that? Everybody okay? All right, let's try the one underneath that. This is example 4. It says Michael leaves home and drives 17 miles west to work. Okay, so he went 17 miles straight to the west. West would be this, okay. And work is there, so that's good. We've got a W, okay. After work, he travels 9 miles to a friend's house. If the bearing from work to the friend's house is, oh great, because everyone measures their path in bearings. It says off of south, he went 24 degrees to the east. Now, what do you know about the angle between south and west? It's a 90, yes? West and south would make a 90 here. So if he's 24 towards the east, the angle in here would be 90 minus 24, 66. Okay. Now it says he travels 9 miles to a friend's house. Okay. So this is 9 miles. The distance between the friend's house and home. So here's the friend's house. And over here somewhere is where he started out at home this morning. Is this a different law or the same? Same. We have still 2 sides and an angle in between. So can you type this one real fast? 17 squared plus 9 squared minus 2 times 9 times 17 times the cosine of 66. And it doesn't matter what order you put the 17 and the 9 in anywhere. Cosine, was it 66? 245.5, and then we square root. Anybody getting that number? 15.7. Okay, did I remember the number right? 245.5, 15.7. Okay. And again, you know, if somebody rounded along the way, they would get a slightly different answer, but it should be pretty darn close. Questions? All right. If you go to 29, at the top of 29A, you can cross off example 6. That one was in degrees and minutes, and we're just not going to do that because we skipped that concept this year. On the bottom of 29A is an example. This is similar to a quiz question on one version, but I will actually, both versions I think have a question about something about a tower and spotting a fire. I did not make it a bearings question on the quiz though, okay? 2 towers at a national park spot a forest fire. Tower A spots a forest fire at a bearing of off of north 38 degrees towards the west, and Tower B spots the fire at a bearing of north 48 degrees east. If Tower A is 729 miles directly east of Tower B, then find the distance from each tower to the fire. So let's draw a nice east-west line. And it says 729 meters, but Tower A is to the east of B. So if this would be the direction east and west, A is to the east of B. Does that seem okay with everybody so far? All right. So there's a fire out here between them somewhere. We're going to put a line here. Both of them say off of north, so that's why I'm drawing my lines to the north here. Okay, so Tower A spots at a bearing of 38 degrees towards the west. So if this is an N for north, badly drawn one, it goes off 38 degrees turning towards the west. Tower B spots the fire at a bearing of off of north 48 degrees towards the east. Okay. Okay, we're just going to draw a really big fire out here because I can't really make those meet very well. That's our fire. Okay. Find the distance from each tower to the fire. Okay. What do we know here? One side of the triangle. That's all I have. Can I figure out this angle? That would be between a northwest and an east-south, should be a total of 90. So 90 minus 48 is 42, I think. How did I do? And then over here, 90 minus 38 inside over here is 52. How did I do there? Okay. Can you tell me right now who's closer to the fire? The guy at A or the guy at Tower A or the guy at Tower B? Okay. Yeah, you got to think about this carefully. This guy is, this side is got to be shorter than this side because it's opposite a 42 versus a 52 degree angles. Everybody good? So it's actually A that's closer, right? The shorter side is the side coming out of A. All right. I think one of the quizzes asks, it gives you the picture, I think, but it asks find the distance to the closer tower. I mean, you could find both of them and then figure out which one's closer, but the one across from the smallest angle is closer. Okay. What are we supposed to be? Find the distance to each tower. Okay. Law of cosines, law of sines. Do we have something across from something? Can we have something, we can't use law of cosines, but can we have something across from something? Well, if we have a 42 and a 52, do we know this angle up here? This totals 94. Doesn't that leave 86 degrees in our triangle up there? Now, can we say we have something across from something? The sine of 86 is across from 729. In the same way that, okay, this 38 was a degrees. Remember, we're trying to find the side and this side. I guess I should call it B and A. This would be side B. This would be side A. So the sine of, what do you want to do first? The short one? 42 is across from B. This one asked us to do both, so then we'd have the sine of 86 is across from 729 in the same way the sine of 52 is across from A. All right, good old cross multiply and divide. Whew, I'm struggling typing today. Anybody get 489 we'll go with on that one? And that's actually the side B, or from tower A. Ooh, yep, I can spell tower. I can spell from. Oh my goodness. Yep, still can't spell from. All right, anybody do the second one already here? How far is tower B away or side A? Nobody already typed? This calculator's. I don't think I have my calculator. Guess I will type 729, sine of 52. Somebody got it already? Give me a shout. 575.9. Anybody else? $575.9. And again, if you were off a little bit, it's okay. Depends if you rounded along the way. There's not a lot of need to round along the way on these. That was meters, this was meters, and this would be from tower B. There I go, spelled it right. Okay, questions? All right, so we reviewed law of sines, law of cosines so far. This is on 29B. Says Philadelphia, Pennsylvania is 415 miles directly east of Columbus, Ohio. So I'm going to Philadelphia, Columbus. Oh my gosh, that's supposed to be horizontal line. Don't follow me. Ooh, that's not much better. The bearing from Columbus to Richmond is off of south. Great. So I need to move this whole story so that I have room, because we're going to go off of a south line. The bearing from Columbus to Richmond is over here somewhere. Is off of south, goes 60 degrees towards the east. What does that leave in here, guys? If this is an east-west line and a north-south line, they meet at a 90, so that's 30. Everybody good? The bearing from Philadelphia to Richmond is off of south go 34 degrees towards the east. 90 minus 34 would be 56. Okay. Now my picture makes it look like that's a right triangle, but I don't think it is. That's a total of 86, so that would be 94 degrees, I think. Is that right? Okay. Find the distance from Columbus to Richmond. So I want Columbus to Richmond, that's this side right here. I think I'm missing a number on my triangle. Anybody see what it was? Yeah, there was a 415 they told us here. So the sine of what, guys? Sine of 94 is across from 415 in the same way that the sine of 56 is across from x. And hopefully we get one of these answers. 415 sine of, I thought it was 56, but I could be wrong. Divided by sine of 94. $344.8 is $345 a choice? Yay. Okay, is that the last one? Is that all side all done now for those of you who are caught up on your homework? Okay, that should be everything in the packet finished up. All right, now grab the purple sheet. And this, I think, is a law of sines question. What about this one, guys? If you're trying to find this distance right here, this is x, this side here. Two sides and an angle in between, that is law of cosines. Do you want me to write sines by this one? All right, I want to do number 3 with you because it has 2 things on it that we have not reviewed yet today. So let's do this one together. Calculate the size of the largest angle. Where's the largest angle in this picture? It's got to be across from the longest side over here, yes? Okay, so I'm just going to call this x. When we have 3 sides and we need an angle, we can't use law of sines. We don't know anything across from anything else, but we can use law of cosines. I'm going to make one up like we just did a minute ago, I guess. We use c squared equals a squared plus b squared minus 2ab cosine of c. On the quiz tomorrow, you have to be able to state law of cosines and law of sines, okay? I don't care what letters you use. Like you could say b squared equals a squared plus c squared minus 2ac cosine of b, okay? I don't care which one you give, but you have to be able to give me one. All right, where am I going to put the numbers? What are a and b, guys? The ones next to the angle that we're looking for, right? So we have a 4 squared plus a 6 squared, and over here that is an 8 squared. Because we're going to work this one backwards to find the angle. So then it's minus 2 times 4 times 6 times the cosine of, I'll call it x since it's x on my picture. Okay, does anybody remember how this goes? Because what you cannot do is type all of this in, remember? Because this is glued together. So my suggestion is that we subtract the 4 squared and the 6 squared over to the other side. So I'm going to type 8 squared minus 4 squared minus 6 squared. And then that's going to leave us something that's equal to negative 2 times 4 times 6 times the cosine of x. And then we're going to divide by the quantity negative 2 times 4 times 6 to get rid of all that. So if you wanted to do it all in one chunk, that's what it would look like. I'll do it in 2. 8 squared minus 4 squared minus 6 squared gives me a 12 on the top, and the bottom is a negative 2 times 4 times 6, which is a negative 48. Which is the cosine of x. So then how do we find x? Okay, if you had typed this all, parenthesis, this, close parenthesis, divided by parenthesis, this. Okay, everybody good that 12 divided by 48 is a fourth, so we've got 0.25 and it's negative. But that's the cosine. So to finish, we need to do second cosine or inverse cosine of, whoa, sorry, I typed the wrong thing. You could do inverse cosine of negative 0.25 or inverse cosine of 12 divided by negative 48, depending how you showed your work along the way. Everybody good with 104.5 degrees? Is that what it asks for? Largest angle, 104.5 degrees. Okay. It also asks for the area of the sail. Okay. I'm going to stick another page in here. See next page in my notes, just because I don't want to try to write tiny on this screen. If you have sides of 8, 6, and 4, how do you find the area? Heron's formula says S equals, or the semi-perimeter equals, you add up the sides. Oh, it's going to be a nice even number. We can do that. 18 divided by 2 is 9. Did somebody get 9? If you're going to use your calculator, remember you have to hit enter before you divide by 2, or you have to use parentheses. 8 plus 6 plus 4 is 18, divided by 2 is 9. And then Heron's formula says you take S times S minus A times S minus B times S minus C, and you got to square root it all. So I'm going to have 9 times 9 minus 8 times 9 minus 6 times 9 minus 4. I should do that in my head, but I'm going to do it on my calculator just because a lot of times it's not a nice number that you're typing in. Okay, anybody else get 135 before they square rooted? Okay, so then the square root of 135 is 11.6. And if I go back to the question, these were meters. So what would the label be? Square meters. Yep. How are we feeling? Can do Heron's formula? I know I taught you a little trick to store something, and if you remember that, that's great, but I wouldn't worry about trying to remember it on the test because I think you'll just be doing something silly. I'd rather you just spend the time answering the question. Okay. What would this be if you're trying to find the difference here? Anybody remember? 2 sides and an angle in between is? Okay, then I won't tell you. Anybody? Yeah, this is cosine. Let's talk about number 5. This is, just refer to this picture right here. It's better. And it says the length of AB is 32, 46. Okay. So we know this is across from this. And they want us to find the measure of BAC right here. And it's across from a side that's 15. What can we do here then? Law of sines. So we're going to set up the sine of A is across from a side that's 15 in the same way the sine of 46 is across from a side that's 32. Okay, somebody cross multiply and divide. And you're going to get a decimal. 15 times the sine of 46 divided by 32. And I got 0.3372. And that's the sine of the angle, right? You remember this kind? So you have to undo the sine, or you're going to do inverse sine of that. Number. And I got 19.7. This is when you do law of sines and you find an angle, you are to find angle, and then 180 minus that angle is also a possibility. Clearly not in this picture, but I want to remind you of this because it is on the quiz. If we do 180 minus 19.6 or 7, somebody tell me what that is. 160.3. Okay. Now, in a normal triangle, you'd have to examine that possibility, but clearly it's supposed to be an angle smaller than 46, right, guys? So this is not a possibility. So it's 19.7 degrees. Now, how would you find side AC right here? Ugh. Which I'll call side B. How would you find that side yet? Do we need to use law of cosines? Can't we just find this missing angle up here? 180 minus 46 and 19.7. Let's see, 20. Somebody help me. Something 0.3. 114.3. Thank you. So then we just have the sine of 114.3 is across from B. In the same way, I'm going to use the 46 and 32 since that's what we were given to begin with. All right, I'm just going to let you finish that. I think I had one more I want to talk about. Let's talk about the very last one, and then I'll be done. I need some audience participation here. Landscaping company has to seed the triangular piece of land shown. Calculate the total area to be seeded. So we need the area of this triangle. Do we want to use Heron's formula? No, we could, but we'd have to find this side, and that sounds like a whole bunch of work. There's a really nice short area formula that says A equals 1/2 side A times side B times the sine of C. Do we have two sides and an angle in between? So all we have to do is type 1/2 or 0.5 times 30 times 16 times the sine of 56. Anybody else getting 186.5, or did I type something wrong? I feel like I typed something wrong. It was supposed to be 16, wasn't it? I typed 15. I thought it was closer to 200. I kind of remember. There, now I got 199, yeah. So I got 199 square meters. Or was it 198.9? Okay. And if grass seed costs $19 a bag and each bag covers 25 square meters, find the number of bags needed and how much it's going to cost. So how many bags do we need to buy? 25 meters to cover 199. Are we going to need to buy 8? That's 200. You would be dividing, but I think most of us could figure that out. 8 bags. So times $19. To 152. All right. So you need to finish the purple sheet, whatever we didn't do, okay? I don't know what the rest is. And then look over the review. Now, I'm going to stop the recording